Good morning. We will start session 8 on chapter triangles. So in our previous session we started with an exercise based on Pythagoras theorem and its converse. We will continue with the exercise. Question number 8. Given that a right angle triangle is given where you can say ABC is a right angle triangle at B, O is a point and OF is perpendicular to AB, OD is perpendicular to BC and OE is perpendicular to AC. Right? In triangle ABC, angle B is equal to 90 degree. This is O. So OF perpendicular to AB, OD perpendicular to BC and OE perpendicular to AC. Join OA, OB and OC. So join this part and to this. We have to show that two different set of proving part is given and that is only done by Pythagoras theorem. So how do we consider that now? There are so many 90 degree triangles here to use Pythagoras theorem. Which triangle will help me to get the particular answer? We have to first identify the triangles. Now first see here, where does your OA square, OB square and OC square lie? OA square lies, hypotenuse I am talking about. It lies in these two triangles, OA square. Either I have to choose this or this triangle, right? Where does OB lie? OB lies in this and this triangle. OC lies in this and this triangle. That means hypotenuse is shared by two different set of 90 degree triangle. But which triangle I have to choose, that I should know. How do I know that? Read the further. OD square, OE square. So we have here OD square, OE square. Along with that OF square we have OF square. That means I want OA and OF. That means it is first triangle. Then I want here OD and as well as OB is given. That means it is this triangle. Last part I want BD and CE. No, BD is already given. I want OC and CE. It is this triangle. That means I identified now to prove the first proving part. I need to use these three triangles for my for the Pythagoras theorem to be applied on them. Let's start. In triangle AOF, angle F is equal to 90 degree. So I will write here OA square is equal to AF square plus OF square. Reason, Pythagoras theorem. This is equation 1. Next, I will use for in triangle OBD. Angle D is equal to 90 degree. So this is OB square is equal to BD square plus OD square. So Pythagoras theorem. Equation 2. Last one. In triangle OCE, angle E is equal to 90 degree. If you write the statement without writing 90 degree, it is wrong. I am repeating that again and again. OC square is equal to OE square plus CE square. Reason, Pythagoras theorem. Equation 3. Add equation 1, 2 and 3. OA square plus OB square plus OC square is equal to AF square plus OF square plus BD square plus OD square plus OE square plus CE square, right? But that is not the proof what we want. Our LHS part first as it is OA square plus OB square plus OC square. What else you want in your LHS part? You want OD, then you want OE, and then you want OF, right? Bring it to this side. Minus OD square, minus OE square, minus OF square. What will remain? AF square will remain, that is what you want. BD square will remain, that is what is there. And CE square will remain. That's in your LHS. AF square plus BD square plus CE square. Proved. Right? We finished the first part. Now second part of proof, we want this plus something else is given. Now for that actually we want remaining set of triangles what we have to prove. Now what are the remaining set of triangles which we have not used? This, this as well as this, right? Let's write down that first. Which all triangles were pending? In triangle, this is for the second one. This was for the first one. Now for second one, in triangle AOE, angle E is equal to 90 degree. So I can write that as OA square is equal to, so this is the hypotenuse, OE square plus AE square, right? Now I want this statement to be written in the another way form. So I will write here Pythagoras theorem. So this is equation 4. This equation 4 can also be written as in another form, children. I'll tell you later how to write this and why we have to choose that. Next part, next three set of triangles we will write. Next set of triangle is what here? The remaining part. In triangle BOF, angle F is equal to 90 degree. So it is OB square is equal to OF square plus BF square. Please write the reason, equation 4. Also it can be written as in another form. Last triangle, in triangle OCD, angle D is equal to 90 degree. So OC square is equal to OD square plus CD square, Pythagoras theorem, equation 5, and also can be written as, given as it is. What to be written, I'll tell you. Right? What we already proved some in the previous part here. This was the thing what we proved it. So we know that. Write this proof part. OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. Right? Now choose a pair of a part here, a side square along with another one which you can subtract it and where you can correlate here. Now look, you have OA, children. You have here OE and AE, right? Actually in the answer part we want AE square in the answer, CD square in the answer and BF square in the answer. Suppose if I write this as OA square minus OE square is equal to AE square. Can I write this? This whole is equation 4 only. Do I have this here? OA square minus OE square. OA square minus OE square is what? AE square. I will directly write this as AE square. Okay. Next. OB square minus OF square is equal to BX square. OB square minus OF square is directly what? BX square. Last. OC square minus OD square is equal to CD square. So OC square minus OD square. Directly I can write this as CD square over is equal to what? AF square plus BD square plus CE square. From equation 4, 5 and 6. From equation 4, 5 and 6. Understood what we did? We first proved this part here, right? Then we chose the remaining part of triangle. I had to write this, but I thought I'll make you understand from here only and write. We already have those pair here. A part minus this, we get an answer. That answer is already here. We just substituted and with this we got the result. Next sums. A ladder 10 meter long reaches the window 8 meter above the ground. So always when we talk about a ladder, we always consider this is the ladder and this is the wall. This will be the ground. Always remember that. So if I consider this is A, B and C, a ladder which is 10 meter long reaches the window 8 meter above the ground. Find the distance of the foot of the ladder from the base. Whatever we have chosen, we have to write let AC is equal to 10 meter be the ladder. Then AB is equal to 8 meter be the wall. Right? So BC we have to find out. It's a direct question, children. How do we know that it's a 90 degree? Of course, wall and ladder. Wall is always standing perpendicular with respect to ground. So start. In triangle ABC, angle B is equal to 90 degree. AC square is equal to AB square plus BC square. Pythagoras theorem. 10 square is equal to 8 square plus BC square. 100 minus 64 is equal to BC square. BC square is equal to 36 and BC is equal to 6. Always the root will have plus or minus 2 sign, but here since it is a measurement, we always take plus. Therefore, give the conclusion. What is our conclusion here? The distance of the foot of the ladder from the base of the wall is 6 meter. That's the conclusion. Very simple sum. Next one is also a simple one. A guide wire attached to a vertical pole. Now what do you mean by this a guide wire? For example, if you have seen on the roadside, sometimes there is a string and that string is attached to the electric pole. If you have seen that, something like this. So assume that this is the electric pole and like this there is one string, right? You have seen that? So, okay. So that string what is attached, that is called as a guide wire. Okay. You can see sometimes next time when you go out, please see that the wire where it is standing like a ladder. I mean it is vertically slant height of that which is standing against the pole. That is called as a guide wire. A guide wire attached to a vertical pole of height 18 meter. The pole height is 18 meter. Is 24 meter long. What is 24 meter long? The guide wire is 24 meter long. Of course, it has to be greater than the pole because it is the hypotenuse and has a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be taut? So that means I have to like pull it straight and such a way that I have to stick to a pole. I mean I have to draw this wire and it has to be attached in such a way that the wire, there should be no bend or the wire should not just fall off. It should not sag off. It should be in a straight line. So what distance I have to fix this? Suppose if I have a string here, if I have a thread here, I have to fix a thread to the ground. Till where I have to fix the thread? What is this distance they are asking? So that the string should be straight enough to be attached. Simple 90 degree. It's a Pythagoras rule what we apply here now. So A, B, C. Write down whatever is given. Question number 10. So let AC is equal to 24 meter, that is equal to guide wire, and AB is equal to 18 meter, that is equal to pole. In triangle ABC, angle B is equal to 90 degree. AC square is equal to AB square plus BC square. 24 square is equal to 18 square plus BC square. 24 square is 576, 18 square is 324 is equal to BC square. BC square is 576 minus 324, you get 252, and it is not a perfect square. Factorize. Why? Because BC is equal to square root of 252. Write this in the simplest form now. So 2 ones are 2, 2 twos are 4, 2 six are, 2 fours are 2, sorry, not 2 fours are, 2 six are 12, 2 threes are 6, 3 twos are 6, 3 ones are, 3 sevens are, and 7 ones are. So how do you write this as? We write this in the form of 2 into 2, 3 into 3 into 7. Pair and a pair, it can come out. 2 into 3, root 7. 6 root 7. So BC is equal to 6 root 7 in terms of meter. Always keep this in the simplified form. So give the conclusion to it. How far the base of the pole should the stake be driven? How far should the base of the pole should be driven? 6 root 7 meter. That's all is the answer. Keep it as it is. No more simplifying further with the value of root. Whatever is there, it should be kept as it is. Similarly, we have a next one. An aeroplane leaves an airport and flies due north at the speed of 1000 km per hour, and at the same time there is another aeroplane which leaves the airport due west at the speed of 1200 km per hour. So how far apart will these two planes be after 1.5 hours? So it's the sum about speed, distance and time. So if I have to consider about the direction here, children, so this is north and I can consider this is due west, right? Yes, so this is west. So an aeroplane leaves from the airport. This is the zero terminal from where it can leave. At the speed of, first one will leave at the speed of 1000 km per hour and second one will leave at the speed of 1200 km per hour. After 1.5 hour, how much far they are? That means this distance we need to find out. A, B. Now this is speed they have given. When here speed in terms of the time what they have given, we need to calculate the distance traveled by OA and OB here. Let's write. So we can write here first question number 11. Distance traveled by aeroplane due north, that is equal to OA, that is equal to, now speed is equal to distance by time. So we know that first we'll write So here distance we have to find. Distance is equal to speed into time. So distance traveled by aeroplane due north, that is OA, is equal to distance. Speed is how much they have given. For the first aeroplane, children, how much it was? 1000. 1000 into time is given how much? 1.5. So this is 1000 into 3 by 2. 2 ones are, 2 fives are. 1500 kilometer OA. So this OA is 1500 kilometer. Similarly, we will calculate distance traveled by aeroplane due west. OB is equal to, directly we will write. So this is how much it was here given in terms of 1200, right? 1200 kilometer per hour into 3 by 2. So 2 ones are, 2 six are, 0 0. This is 1800 kilometer. In triangle OAB, angle O is equal to 90 degree. OA square is equal to, AB square is equal to OA square plus OB square, Pythagoras theorem. So OA square is how much? We'll do it here. So OA square is how much? AB square is equal to 1500 whole square plus 1800 whole square. 15 square is 225. 225 0 0, 2 more zeros, plus 18 square is 324. So 324 0 0, 2 more zeros. Therefore AB square is equal to 225 plus 324 will give you 549 0 0 0 0. AB is equal to square root of 549 0 0 and 2 more zeros. Let us leave the zeros apart. We only factorize for 549. 549, is it divisible by 3? Yes, it is divisible. So 3 ones are 3, 3 eights are 24, 3 threes are 9. Again divisible by 3. 3 six are 18, 3 ones are 3. That's all. 61 ones are. This can be written as 9 into 61 into 1, 2, 3, 4. Right? Square root of 9 is 3. Square root of this is 100. Root 61. Therefore, AB is equal to 300 root 61 kilometer. So the answer should be 300 root 61 kilometer only. It will be in the root. You need not simplify the root. Quickly, we will finish the 12th one now. 12th one. Two poles of height 6 meter and 11 meter stand on a plain ground. So let's consider this is two poles of height 6 meter and 11 meter. They stand on the ground. And if the distance between the feet of the two poles is 12 meter. So if I consider AB is one pole, CD is another pole, the distance between two poles is 12 meter. Find the distance between their tops. I need to find this distance. That means I need to draw an imaginary line which is E. So if this is 6 meter, children, this also will be 6 meter and the whole is 11 meter. Right? So this is 5 meter. If this is 12, this also will be 12 because it becomes a rectangle. Now we all know that 5, 12, 13 is a Pythagorean triplet. Answer is 13 here, but still we need to solve. So first of all we need to write, let AB and CD be the height, or we will first write here the measurement has to be written. Let AB is equal to 6 meter and CD is equal to 11 meter be the height of two poles. AC is equal to 12 meter, distance between the poles. Find BD, that is distance between their height, distance between their tops. So ABEC is a rectangle. Therefore, AC is equal to BE is equal to 12 meter and AB is equal to CE is equal to 6 meter. Keep this as this. In triangle BED, angle E is equal to 90. When we talk about pole, they are always perpendicular. So, BD square is equal to BE square plus DE square. So, BE is 12 square plus 5 square, 144 plus 25. So BD square is equal to 169, BD is equal to root 169 and BD is equal to 13 meter. Therefore, distance between their tops is 13 meter. A very simple sum, children. So the next what we have is something what we have to prove in a given set of a right angle triangle or applying Pythagoras theorem. And these sums are very, very important. They are usually asked in examinations. We'll start with the next one, that is 13th one. D and E are the points on the sides CA and BCD respectively of triangle ABC. That means, where it is a right angle triangle? Yes, right angled at C. So if I consider this is C part here and this is B and this is A. So according to them, D and E, so this is D and E, are the points on the side CA and CB of triangle ABC, which is right angle at C. So given, we will write the same thing. In triangle ABC, angle C is equal to 90 degree. D and E are the points on CA and CB respectively. Join DE. Okay. Along with that, how do I know I have to join? Because they have given us AE square plus BD square. AE square, that means I have to join AE also. Then BD square, I have to join BD. That is how I come to know. So join DE, AE and BD. Right? So how many 90 degrees? This is one right angle triangle. But how many triangles we can form from that? Let's see. So first of all, in triangle ACE, angle C is equal to 90 degree. So it is AE square is equal to AC square plus CE square. Pythagoras theorem, children, always you have to write equation 1. So let us write all the forms of a, let us choose all the forms of a right angle triangle here, right? With respect to that, we will get all these things. Next is BD square we want. So let us choose BD square, right? So BCD. In triangle BCD, angle C is equal to 90 degree. So this is BD square is equal to BC plus CD square, equation 2. Now actually we want here in terms of AE square plus BD square. But if I add AE and BD, that is AE square plus BD square, I will not get the actual result. Will I get? No. That means I need to form some more triangles here. Which are the other combination? In triangle ECD, angle C is equal to 90. Where is ECD? ECD. So I will write that as ED square is equal to CE square plus CD square, equation 3. Next children, the last triangle what we have in triangle ACB, angle C is equal to 90 degree. So if angle C is equal to 90 degree, then AB square is equal to AC square plus BC square, equation 4. Right? We have all these 4. But actually in the question if you see, I want in the form of AE square plus BD square. So everywhere you have to write Pythagoras theorem. I have just missed it. But please make sure you write it. Add equation 1 and 2. So if I add equation 1 and 2, what do I get? AE square plus BD square is equal to AC square plus CE square plus BC square plus CD square. But that is not the actual result what I want. But my LHS part is same. Now look for the other options children here. AC and BC. AC square plus BC square is actually what? AB square. Make use of it. AE square plus BD square is equal to AB square. CE square plus CD square. CE square plus CD square is equal to ED square. In other terms, I make this as DE. ED or DE plus DE square. From equations 3 and 4. That is what we wanted. AE square plus BD square is equal to AB square plus DE square. Hence proved. Let's go to the next one. 14th one. So 14th and 15th are usually important. So these sums are asked in different variants actually. And there are even several methods to prove this sum. I am choosing or I am using one of the method, easiest one. So in case if you come across in your school or anywhere any other method, you feel that is easy or this is easy, you can adopt any method you want. Okay. 14th one. The perpendicular from A on side BC of a triangle ABC. Figure is already given. So let's draw. So this is perpendicular. This is D. This is C. This is B. And this is A. The perpendicular from A on side BC of a triangle ABC intersects BC at D such that in triangle ABC AD is perpendicular to BC such that DB is equal to 3 times of CD. And that's all they have given. To prove 2AB square is equal to 2AC square plus BC square. This is given. Proof. Okay. Again, we'll start from the same thing. In triangle ABC, what they have given? DB is equal to 3 times of CD. Keep this as it is. DB, that is, this is equal to 3 times of this. Right? If I add this 3 times, I am going to get DB. Next, BC can be written as CD plus DB. Correct? BC can be written as CD plus DB. So CD as it is. What is DB? DB is 3 times of CD. So BC is 4 times of CD, or CD is 1/4 BC. I'm just going to highlight all these things because I'm going to use them later. So BC is equal to 4 times CD, or CD is equal to 1/4 BC, right? So DB is equal to 3 times CD is given. I just wrote that BC is equal to CD plus DB, where CD as it is, DB's value is 3 CD, BC is equal to 3 plus 1 is 4, or CD is equal to 1/4 BC. As it is, children. Okay, that's from the given we have found the values of the other sides. Now let's quickly start with the triangle where we have Pythagoras theorem where we can apply in that. In triangle ADB, the bigger triangle I have chosen, angle B is equal to 90 degree. So it is AB square is equal to AD square plus DB square. AD square as it is, no changes, is equal to AD square also as it is. What is DB? DB is equal to 3 times of CD, what we have written here, or we can also use this in terms of, we can use this value. DB is equal to 3 times of CD. So 3 times of CD whole square. So we will write this as AB square is equal to AD square plus 9 CD square, equation 1. So next part I will do it here. In triangle ADB is over. In triangle ADC, angle D is equal to 90 degree. So AC square is equal to AD square plus CD square. AC square as it is, AD square also as it is, plus CD square is equal to. Now see children, don't substitute the value of CD as of now. We will keep it. Later where all we require, there we'll make use of. Because already we have here CD. There also we have CD. Keep it as it is now. CD square. Equation 2. Pythagoras theorem here. So subtract equation 1 and 2. So it is AB square minus AC square is equal to AD square plus 9 times of CD square minus AD square minus CD square. Why minus? Because when I take this whole term as minus bracket when we write, we substitute that. AD square and AD square will get cancelled. AB square minus AC square is equal to 9 minus 1, 8 times of CD square. What is CD equal to? CD is equal to 1/4 BC. Why? Because we want the whole thing in terms of AB, AC and BC. We have AB, we have AC. CD is not required. So AB square minus AC square is equal to 8 times of CD. CD is 1/4 BC whole square, right? 8 outside. AB square minus AC square is equal to 8 by 4 4s are 16 BC square, 8 1s are 8 2s are. So AB square minus AC square is equal to BC square by 2. Cross multiply this here. 2 times of AB square minus 2 times of AC square is equal to BC square. Now rearrange. 2 times, this 2 will go here, whole I have multiplied. 2 times of AB square is equal to, this 2AC will shift this side, 2 times of AC square plus BC square. hence proved, right? So it's only substituting the values what we have got here in the given Pythagoras part. Please don't forget to write everywhere Pythagoras theorem and Pythagoras theorem here. Quickly we'll move to the next one, 15th one. So 15th one, they have given an equilateral triangle and there we have to prove a particular type. Let's see how to do that. It's a very important question, what you can say. Several variants of these types only are usually asked from Pythagoras part. Okay. So according to the question, an equilateral triangle ABC. So ABC is an equilateral triangle. D is a point on BC such that BD, we'll write here first of all children, 15th one. ABC is an equilateral triangle. That means AB is equal to BC is equal to AC. D is a point on BC. D is a point on BC such that they have given the relation BD is equal to 1/3 BC. Prove that. Nine times of AD square is equal to 7 times of AB square. Okay. We have a construction here. Construction. Draw. What we consider here? AP perpendicular to BC. Now, it's nothing but you are drawing an altitude. An altitude drawn to the base of the equilateral triangle divides it into equal parts. We all know that. Okay. So, proof. In equilateral triangle ABC, AP is perpendicular to BC. This implies BP is equal to CP. These both are equal part. Okay, this much you keep it as it is. And they have also given one point saying that BD is equal to 1/3 BC. So this also implies that it is 1/3 AC. BD is equal to 1/3 BC. It is also 1/3 AC. Why? Because it is an equilateral triangle. All the sides, if it is 1/3 of this, it should be 1/3 of the other side also. Since all the sides are equal, keep this as it is. So let's come to this. PP is equal to CP. This is from the given part what we have written. Now this is from the perpendicular what we have drawn. BP is equal to CP, right? So this implies BP is equal to CP, which is nothing but I can write this as half of BC. Can I say BP is equal to PC, nothing but half of BC equal to half of AC. Can I use this? All the sides are equal in the equilateral triangle. So these are few relations what we have arrived from the whole given part, same like the previous sum. See, whenever you get such type of sum, BD is equal to 1/3 of another side, try to arrive at several relations like this. It will be helpful for solving the further part of the sum. Now done. We are done with all proving part here. Next, let us choose the triangle. To choose Pythagoras theorem. In triangle ABP, where is ABP? ABP, angle P is equal to 90 degree. That means it is AB square is equal to BP square plus AP square. Pythagoras theorem. Substitute the values whatever you know. AB square as it is equal to, what is BP is equal to CP is equal to half BC or half AC. Anything can be taken here. right? So we consider this as AB is equal to BC is equal to, that is also equal to half AB, children. Yeah, that is also 1 point I will write. 1/3 AB. BC, AC, AB. These are the sides of the equilateral triangle which I had missed. Very clear? BC is equal to AC equal to AB. Anything I can use. So BP is equal to, if I use BC, it's of no use. If I use AC, it's of no use. I can use AB because I already have AB here. So I will write BP is equal to half of AB whole square plus AB square as it is, nothing to be done with this AB square. Now, AB square is equal to 1/4 AB square plus AB square. So, if I shift it this side, AB square minus 1/4 AB square is equal to AB square. 1 minus 1/4 is 3/4. AB square is equal to 3/4 AB square. Keep this as it is. Let us use this somewhere. Okay. Next part. One part of triangle part proving is over. Taking is over. ABP is over. ABP is over. Let's take the another side, or instead of that, let us take this part of the side. In triangle ADP, angle P is equal to 90 degree. That is why we have taken this perpendicular bisector. Use AD square is equal to AP square. Understood, children, why I did not take this side? Because I wanted AD square in the question. See, I took this part of triangle, right? Because I wanted one side, AB square here. I did not take this side because even if I take this side, I can correlate with here. I wanted something in terms of AD, so I have taken this triangle. So, AD square is equal to AP square plus PD square, or DP square we have, okay, DP square. Pythagoras theorem. AD square as it is. We don't have anything for AD square. Keep it as it is. AD square. What is AP square value? 3/4 AB square. Write it. 3/4 AB square. AB square itself is 3/4 AB square as it is. DP. DP can be written as whole BP minus, see, I want this measurement. So this is whole minus part. BP minus PP minus BD whole square. Very clear? Next. AD square is equal to 3/4 AB square plus, what is BP? BP is equal to CP. PP is equal to CP is equal to half BC, half AC, half AB. Half AB minus, what is BD? So what is BD here? Search in the BD part. BD is equal to 1/3 BC, 1/3 AC, 1/3 AB. 1/3 AB. Very clear, children? Right? So AD square is equal to 3/4 AB square plus LCM is 6. So here 3s are 2s are. So 3AB minus 2AB whole square. AD square is equal to 3/4 AB square plus 3 minus 2 is 1. So this is AB upon AB square upon 36. Very clear? AB whole square was there here. So AB square upon 6 square is 36. Now take the LCM for 4 and 36. I hope this line will be visible to you all if I do it, or I'll do one thing, children. Shall I rub this given and construction part, this much part will be enough for me to prove it. Okay, I just erase this part, you all can just copy this down. So I'll solve the sum here. A very small part is left. Okay, I'll just draw the line. So there, if I take LCM, what do I get? 36 is LCM. So 4, 9 4 is 36. AD square is equal to 9 3s are 27 AB square plus AB square. Shift 36 this side. 36 AD square is equal to 28 AB square. Done. 36 and 28, they are from the same tables. So we can, what answer do we want? We want answer in terms of 9. So 4 9s are 4 7s are. 9 times of AD square is equal to 7 times of AB square. Proved it? Quite lengthy, but if you do it systematically one after the other, main thing is this, what we have written here in the starting. And you should know what to use where. If you just sit and say that here instead of BP, you will use BC, and here somewhere instead of AB, you will use AC, then it is wrong. Try to use the same side because it is an equilateral triangle. That is why this relation I have written here. Right? With this relation, we will substitute and we will get it. Do it slowly. You will get, it will get same factors, it will get divided. 9 times of AD square is equal to AB square. Quickly, we will finish the remaining 2 also. Again, it's in an equilateral triangle. We have to prove something. You need to practice a lot for such type of sums. It is sometimes there are chances you will go wrong, you will not understand what to substitute. So lots of practice is required. Practice is done only if you write it again and again, not read it. Okay, let's start with the next one quickly. 16th one, in an equilateral triangle. So A, B, C is an equilateral triangle. Prove that 3 times given ABC is an equilateral triangle. So AB is equal to BC is equal to AC is equal to A units. We will consider each side of an equilateral triangle as A units. Okay. And let AD be the altitude. So AD is equal to X units. The measure of the altitude is X units. To prove, 3 times, or we'll just write 3 times the square of one side. The 3 times the square of one side, that is 3 times the square of one side of an equilateral triangle is equal to 4 times the square of an altitude. Is it clear what I have written? This is nothing but 3 times the side of an equilateral triangle is equal to 4 times the square of the altitude. What we have to prove it here. So let's do this and let's start by using Pythagoras theorem here. Prove in triangle. So which triangle would you like to choose here? So we'll choose in triangle ABD. Angle D is equal to 90 degree. So AB square is equal to AD square plus BD square. Substitute the values. What is AB square? A square. What is AD square? X square. And what is BD square? BD square is a by 2, because if this is a by 2 and this is a by 2. It divides equally altitude. A by 2 whole square, right? So a square is equal to x square plus a square by 4. Take LCM. A square is equal to 4x square plus a square upon 4. This 4 you can shift here. 4a square is equal to 4x square plus a square. I'll do it here, children. 4a square minus a square is equal to 4x square. So this is 4 minus 1 is 3a square is equal to 4x square. That is nothing but 3 times of the sides of an equilateral triangle. Square of the side of an equilateral triangle is equal to 4 times the square of its altitude. That is what we proved here. I took that in terms of a and x. If you don't want to take that in terms of a and x, you take that in terms of AB, AD and AC. Anything. But we need to mention what we have taken here. And the last sum of the exercise. It's an MCQ, but usually asked as an MCQ only. We need to identify what is the measure of an angle B. If it satisfies a right angle triangle or no, we have to check. And what if it does not satisfy a right angle triangle? That trick you will come to know once you learn the chapter trigonometry. So let's see here. We also have an optional exercise for this chapter. So that will be done in the next session. Take the correct answer. Let us just assume a triangle. It is not a right angle triangle, we know that. But let's just assume a triangle. And just mark it. AB is equal to 6 root 3. According to our BC is equal to 12. AC is equal to 12 and BC is equal to 6. Looking at this, you can tell it is 90 degrees. But I don't know. I have to check whether these sides are of an equilateral triangle or not. So we will find out 17th one. First we'll find what is AB square. 6 root 3 whole square is equal to 36 into 3. It is 108. Correct? Yes. Next is BC square is equal to 6 square is equal to 36. AC square is equal to 12 square, that is equal to 104. If you see here, 108 plus 36 is actually giving you 144. This implies that AB square plus BC square is actually AC square. By converse, angle B is equal to 90 degree. Reason is not required here because MCQs nobody will ask you. But I have just solved it. See, there are 3 sides given. Check whether the 3 sides will satisfy the Pythagorean triplet or not. If it satisfies Pythagorean triplet, then the angle which is opposite to the greatest side, that is 90 degree. It satisfies here. That is why angle B is 90. If it does not satisfy, what type of a triangle, again it can be found out. What is an angle, that you again learn in trigonometry chapter, children. So here let's just fix to this. With this we complete actually the chapter triangles, but we still have an optional exercise. So we complete this exercise. Optional exercise will be done in the next session. Please practice this chapter. Along with, there are some worked examples about how to get that 9AB square and 7AB square. Similar sums are also there in worked examples. So please practice. Thank you.